carboxylic acid. So if you want to make the ester, alcohol, and carboxylic acid, they can react with each other to form ester. Because now at this moment, we're talking about the nomenclature. So that's why I'm going to tell you the names of the different types of ester. Now, first of all, look at the number of carbon atoms which are attached with the single bonded oxygen. Either your organic compound is in this form or in this form. How many carbon atoms are attached? Just one. As you can see, just one carbon atom. Now, use the alcohol as a alkyl in ester. Use as a alkyl. Mean if you have one carbon, it means this part is actually coming from methanol. So you can use the methyl word. Okay. You can use the methyl for this. If there is just one carbon, methyl, two carbon, ethyl, three carbon, propyl, four carbon, butyl. Okay. So I will have to write down the name from this carbon or this group because it contains one carbon. So I can write this is methyl. Now count the rest of the carbon. Now this part contains just one carbon, so this is also meth. And the ending code is NO8, so this is the complete name of this ester, methyl methanoate. Methyl is coming from alcohol and methanoate from carboxylic acid. Okay, so if you add 8 with any part of the ester, it means that belongs to carboxylic acid. Let me draw some more esters. Now you have an ester like this. If I add one hydrogen here and two carbon here, so this is the structural formula of the ester. Now, look at the number of carbon atoms. There are two carbon atoms, so this is ethyl. There is just one carbon here, so this is methanoate because the ester is there. So the complete name of this organic compound is ethyl ethanoate, ethyl methanoate. Now, if I add some more carbon on the left hand side, if I add just one carbon on the left hand side, you can change the name of the organic compound. If I add just one carbon, so you can write like this, CH3. Now there are two carbon atoms, so you can write the name as a ethyl ethanoate. Now both these sides contain two carbons, so this is ethyl ethanoate. Now as you can see the structure, this is ethyl ethanoate. If I add one more carbon, so we'll have to make like CH2, then CH3. Now this is propane, this is ethyl, and this is propanoate. Now this is ethyl propanoate. Ethyl propanoate. This part is ethyl, this is propanoate. If I add one more carbon on this side, I will have to make like CH3. Now this is propyl propanoate. Propyl propanoate. Now, if you look at the structural formula, this is the structural formula. So if you count the number of carbon, hydrogen, and oxygen, let's start from the simple compound that you have started from this ester. This is methyl methanoate. Okay, if I add one more carbon on the left hand side, now this is, sorry, this is This is methyl ethanoate. Now count the carbon and hydrogen atom because they contain CH in three elements CHO. Now there is one carbon, or two carbon, sorry, two carbon. How many hydrogen? Three, four, and how many oxygen? Two. Now Look at this CHO, three carbons are there, six hydrogens are there, and two oxygens are there. So the general formula of any ester is CnH2nO2. It means that both the carboxylic acid and the ester, they have the same general formula. Sometimes if you people have any general formula, like if you have a general formula C4H8O2, and if you want to draw the different possible structures of C4H8O2, you can draw the structures of carboxylic acid, and you can also draw the structures of esters. The carboxylic acid must contain OH as a functional group, and esters must contain COO as a functional group. The acids, they can react with the metal, they can react with the metal oxide, they can react with metal carbonate and metal hydroxide. Esters are the sweet smelling compound. So if your task is to draw the sweet smelling compound of C4H8O2, then you will have to draw the ester. But if you people are going to draw the organic compound which can react with metal or which can react with metal oxide or with metal carbonate, then try to draw the structure of carboxylic acid.